In this video, we will find the area between two curves with respect to the x and y axis and find areas using subregions. The definition is area equals the integral from a to b of f of x minus g of x dx. For example 1, we will be integrating with respect to x. Step 1. If you aren't given the points of intersections, you have to solve for them by putting both equations in terms of x and setting them equal. The x values you solve for will be the bounds. Step 2. Set up the integral using the bounds from the previous step and subtract the bottom curve from the top curve. Step 3. Solve the integral by either using a calculator or solving analytically. So the two equations are y equals x squared and y equals x plus 2. So to find the intersection, you want to set both of them equal to each other. And then solve. So in order to solve for x, you have to factor them. And then set each one equal to 0. So then you get x equals 2 and negative 1, and those will be your bounds. The next step is to set up the integral, and as we solved in the last step, the bounds are negative 1 to 2 of the top curve, which is x plus 2, minus the bottom curve, which is x squared dx. So we have the integral from negative 1 to 2 of x plus 2 minus x squared dx. So to solve analytically, you first want to find the antiderivative. So that would be x squared over 2 plus 2x minus x cubed over 3 from negative 1 to 2. So then you want to plug in the upper bound into the antiderivative and then subtract the substitution of the lower bound. So it would be 2 squared over 2 plus 2 times 2 minus 2 cubed over 3 minus negative 1 squared over 2 plus 2 times negative 1 minus negative 1 cubed over 3. After plugging that into the calculator, you get 9 halves or 4.5, which is the area between the two curves. For example 2, we will be integrating with respect to y. Step 1. If the equations are in terms of x, convert them to in terms of y by isolating x. Step 2. Find the points of intersections. These bounds will be the y values instead of the x values. Step 3. Set up the integral to find the area using the bounds solved in the last step and subtract the left curve from the right curve. Step 4. Solve the integral either using the calculator or analytically. Since neither of these curves are in terms of y, we have to convert them. So for y equals x squared, that would change into x equals the square root of y. And for x plus y equals 2, that would convert into x equals 2 minus y. Since we can clearly see the intersection, we can skip step 2 and set up the integral. So it's the integral from 0 to 1 of the right curve, which is 2 minus y, minus left curve, which is the square root of y, dy. And when you plug that into the calculator, you get 5 over 6, or 0.833, and that's the area between the two curves. Example 3. Finding area of subregions. Step 1. Find the points of intersections, which will be the bounds. Step 2. Set up the integrals of each subregion. Step 3. Solve either using the calculator or analytically.
So we can skip part 2 because we already know the points of intersection to set up the bounds. So we start with the first region from negative 2 to 0, and we're going to subtract the bottom curve from the top curve. So that is 2x cubed minus x squared minus 5x minus negative x squared plus 3x dx, and add the next region from 0 to 2 of negative x squared plus 3x minus 2x cubed minus x squared minus 5x dx. And using a calculator, you can find out that the answer is 16.
That's it, and thanks for watching.